addition principle. So when solving a linear equation, our goal is to have variable, right? So this could be like x, a, y, z, right? Any letter. And then on one side of the equation, and to find the value for the variable to make the equation true. So the addition principle, right, is we're going to move the negative term, and we do the opposite, and we add. However, anything we do to one side of the equation, or equal sign, we must do to the other side. So let's think about this for a minute. So if you have to do it to the other side, so let's think about kind of, right, like if you were to weigh something back in the day, right, there would be something like this, right, where, like they did this in chemistry, where you would have to like have these weights, and then you can go ahead and measure what you're trying to do, right? So in order for them to be equal, right, you either, say if you add something on this side, then you have to add the same amount on that side. Or if you remove something, like a certain amount, you'd have to remove the same certain amount for this to be equal, right? And this equal means like it's going to balance, right? And if it's not balanced, like say if you just took something away, or say you put something just on one side, it would be off balanced. And so the same thing is true when we're looking at linear equations. So let's go over some examples here. Example 1. During the coronavirus pandemic, 90 students who lived in the dorms went home, and 32 students remained. How many students lived in the dorms before the pandemic? So we're going to look at this, right? We're going to use this as our equation in order to solve. So if we have x minus 90, which is equal to 32. So our goal is we want to get x by itself, and we need to find out what the variable is in terms of the value. And so how we do this, right, is if this is the addition principle, so we're taking what's negative, or what we're subtracting, and we're going to go ahead and add. And so we can kind of think like this. So we're going to go ahead and add here. And then remember our balance beam, right? If we do something to one side, we have to do it to the other side. So we're going to go ahead and add 90 to that side. Now what it does over here is it just makes it so it's 0, right? And then we just have x plus 0, so it's really just x. And that's equal to 32 plus 90, so that's 122. So the number of students then would be 122 students. We found what x is, right? So this is saying if we go back, we put 122 in there, we subtract 90, we would get 32. So that value has to be 122 in order for this to be a true statement. So let's look at another example. Example 2, use the equation below to solve. So here we have this equation, x minus 108 equals 125. So we want to do the opposite of this subtraction, and we want to get the variable by itself. So we just go ahead and add 108 to both sides, right? We do it to one side, so we have to do it to the other. This just becomes 0, which is perfect. And then on the right, we can either get our calculators out, or we can just go ahead and do this really quickly in our heads. So 5 plus 3, 13, this is 3, and then that's 2. So x is equal to 233. And so you can go back and check by putting this value into here to make sure it equals 125. So if you put that in, if it equals that, you know you did this right, and so it's always a way to check yourself. Now example 3, we're going to solve for n in the equation below. So we have 63, which is equal to n minus 18. So we need to find the value for what n is to make this hold true. So in order to go ahead and solve, I'm going to go ahead and add 18 to both sides. This gets rid of it now on the right-hand side, so that's just 0. And that equals n, right? N plus 0, which is just n then. And then we have 63 plus 18. 3 plus 8, right, is 11. This is 8. So n is equal to 81. And so we can go ahead and check this. So let's go ahead and check, right? So if we have, this is 63, and if this is 81 minus 18, let's go ahead and solve for that. And that's 63. So therefore, this checks out.